All right, so we're going to do the fundamental theorem of algebra today. You already know that the degree of the polynomial matches the number of answers, and that's going to include multiplicity. So basically, we're working backwards. I'm going to give you the answers, you're going to turn them into factors, and then we're going to write them as polynomials. So just understand that I'm going to give you the zeros, the answers, the solutions, such as, I don't know, 2 and -3, and then you're going to turn them into factors. Okay, so 2 would turn into an x minus 2 because that's the factor that would give me a solution of 2. And -3 would turn into x plus 3 because that's the factor that would give me a solution of -3. What we do have to understand is that there's something called conjugates, and we've worked with conjugates already this year. But what we're talking about in terms of conjugates is if the square root of a is an answer, then negative square root of a is also an answer. If bi is an answer, then negative bi is also an answer. So we're usually only going to give you one or the other, and you have to know that the opposite is also an answer. So why is that? Where does that come from? That's because if you have a square root or an imaginary, that's going to come from taking the square root of either a positive non-perfect square or taking the square root of a negative. For example, x squared minus 2 equals 0. If we solved that, we'd have x squared equals 2. When we take the square root, whenever you take that square root, you end up with plus or minus the square root of whatever number. So in this case, I have positive radical 2 as an answer and negative radical 2 as an answer. Same idea if I had imaginary. So if I had x squared plus 4 equals 0, I'd have x squared equals -4. When I take the square root of each side, now I'm going to have plus or minus 2i. So we never end up with just one imaginary or just one radical. You always have the plus and the minus, and that's coming from just this solving here. So our first example is going to be to write a polynomial given the zeros. So write a polynomial given the zeros. All right, so example 8 here. I'm giving the zeros of -1, 2, and 4. First thing you do is you check, are there any imaginary or irrational zeros that we have to find the conjugate of? The answer is no. If there were, we want to make sure we included those as well. So now we'll take our zeros and we'll turn them into factors. So -1 would turn into x plus 1, +2 would turn into x minus 2, and +4 would turn into x minus 4. Once we've done that, now we can go ahead and FOIL them all together. So I'm going to FOIL those two, and I'll have x squared, x times x times -2 is -2x, 1 times x is x, 1 times -2 is -2. We still have that x minus 4. Go ahead and combine those like terms. So x squared minus x minus 2 times x minus 4. Now we're going to multiply this trinomial times a binomial. So take x squared times each piece in the binomial. So x cubed minus 4x squared. And then take -x times each of those pieces. So -x squared plus 4x. And then -2x times -4 also. So minus 2x plus 8. Combine your like terms. So x cubed minus 5x squared plus 2x plus 8. So that's going to be our answer. Put an f of x here because we're writing that polynomial function. Okay, so let's try our next example. So basically, real quick, back to this one. If I asked you to solve this, you would use your P's and Q's to figure out what your solutions were. Hopefully you'd find -1 first, and then you'd go ahead and you'd factor to find the remaining 2 and 4. Notice it's a third degree polynomial. We started with 3 answers. All right, so now I have 1, 2, and 5i. So notice here that 5i is an imaginary, so it's not given to us, but we have to know that -5i is also one of our solutions. So what I always do is turn this into our factors, so x minus 1, x minus 2, x minus 5i, and x plus 5i. So this is going to be plus 5i because my solution was -5, and this is minus 5i because my solution was positive 5i. It's always important, multiply the conjugates together. Okay, it's not that it won't work if you don't, but multiplying the conjugates together is going to save you a lot of trouble. And then we'll also multiply these together. So I'm going to FOIL these two binomials that don't include conjugates, and I'm going to FOIL these conjugates together. Let's do the conjugates first because I want you to understand why we're choosing to do this. So x times x is x squared. X times 5i is a positive 5ix. Negative 5i times x is negative 5ix. And negative 5i times positive 5i is a negative 25i squared. So there's a couple things coming back to us here. One, notice that when I multiply the conjugates, those middle terms are going to cancel out. That's going to happen every single time. That's why you have conjugates. That's what it means to be a conjugate, that they're having those opposite signs. When you multiply them, those drop out. Now, the second thing we have is this I squared. Remember that I squared is really negative 1. So this becomes x squared plus 25. Okay, take a second and think about that x squared plus 25. If I were to solve that, I would have gotten plus or minus 5i. Try it if you don't believe me. All right, so now I've FOILed those together. Now I'm going to go back and I'm going to FOIL these two together. So x squared minus 2x minus x plus 2. Combine my like terms. So x squared minus 3x plus 2. Now I'm not done, but what I've done is I've gotten rid of those imaginary and those i's in my problem, and then I've just created a trinomial times a binomial again. So we'll FOIL one more time here, x squared times x squared and 25. So x to the fourth plus 25x squared. Negative 3x to both of those pieces, so negative 3x cubed minus 75x, and then the 2 to both of those pieces, so plus 2x squared plus 50. So now I have x to the fourth minus 3x cubed, we're trying to keep this in standard form here, plus a 27x squared. The 27 is coming from 25 plus 2, then minus 75x plus 50. And then we'll go ahead also put that f of x in front of that and call it today. All right, so we're going to try just a couple more here and make sure we are in a good place. We'll do example C here, which is 3/2 and negative square root of 5. Okay, so I have two solutions here. That's given to me, but this negative square root of 5, I have to recognize that that's a conjugate, so I'm also going to have positive square root of 5. So you always have the opposite sign of what you were given also. So now I have 3 zeros, which means my final polynomial is going to be something x to the third. So now I've got to turn these into solutions. So if you're not comfortable with turning this 3/2 into a solution, what you can do is kind of work backwards and say, okay, x equals 3/2. What we're trying to do is get it set equal to 0. So multiply by 2 on each side. So now we have 2x equals 3. Subtract 3 from each side. So that's turning into a 2x minus 3. Okay, because this would be 2x minus 3 equals 0. So my factor is a 2x minus 3. Notice that this sign here is a subtraction and I have a positive answer. That always happens. Your sign always changes. And then this one is going to be an x plus the square root of 5. There's that sign change again. And this radical 5 would be an x minus radical 5. Now remember I said that you always want to go ahead and multiply your conjugates first, so I'm going to start with that. That's going to help me eliminate these radicals from my problem right away. So x times x, and x times negative radical 5, negative radical 5x. Radical 5 times x, positive radical 5x. And then positive radical 5 times negative radical 5 is going to be negative 5. Okay, when you're multiplying two radicals that are the same, that's like the square root of 25, which is regular plain old 5. Take a look at these terms. Those middle terms are going to cancel out. That's coming from that conjugate. So I end up with x squared minus 5, and I still have this 2x minus 3 that I'm going to now FOIL with the x squared minus 5. So 2x times x squared is 2x to the third. 2x times negative 5 is negative 10x. Negative 3 times x squared, and negative 3 times negative 5. Just make sure, notice that these terms are switched around. We want to put this in standard form, so we're going to go ahead and change that to 2x cubed minus 3x squared minus 10x plus 15. All right, we're going to do just one more. It's going to be the biggest one of them all. So let's go back up here to D. And we're going to have a 2, a 2i, and a negative square root of 6. So as we look at this, we have two things that have conjugates. We have the 2i, which means we're also going to have a negative 2i, and we have the negative radical 6, which means we'll also have a positive radical 6. So as we turn all of these into factors, kind of keep your conjugates together because we know we want to FOIL them. So this 2 is going to become x minus 2. 2i is going to become x minus 2i. Negative 2i is going to become x plus 2i. This negative radical 6 is going to be x plus radical 6, and this positive radical 6 will be x minus radical 6. All right, so I'm going to FOIL these conjugates together, I'm going to FOIL these conjugates together, and we're going to save this x minus 2 for the very end. So I'll start with these, x minus 2i, x plus 2i. So I'll have x squared plus 2ix minus 2ix minus 4i squared. So remember that that 4i squared is going to become plus 4. So x squared plus 4, those conjugates canceled out. We still have this x minus 2. And then if I FOIL these together, I'll have x squared minus radical 6x plus radical 6x minus 6. So those cancel out, and I have x squared minus 6. Now it doesn't really matter how you FOIL them together, honestly, just pick. So I'll have x cubed plus 4x minus 2x squared minus 8 times x squared minus 6. You don't need to worry about putting this into standard form just yet because we're not done. We still have to FOIL. So x cubed times x squared is x to the 5th. X cubed times negative 6 is negative 6x cubed. 4x times x squared is going to be 4x cubed. 4x times negative 6, negative 24x. Negative 2x times x squared, negative 2x to the 4th, plus 12x squared, running out of room, minus 8x squared plus 48. So now just be super careful, put this in standard form. X to the 5th is going to be my degree. Notice that I have 5 answers there once I've taken care of my conjugates, so x to the 5th totally makes sense. So I'll have x to the 5th minus 2x to the 4th. So I did my x to the 5th, my minus 2x to the 4th. I've got some cubes here, so that's going to be a negative 2x to the 3rd. I've got some squareds here, so that's going to be a plus 4x squared. I've got only one x minus 24x plus 48. Put an f of x. I think this f of x here is already typed in the computer for you. All you should have to type in is this. Make sure it's in standard form and watch your signs.